Hello everyone, welcome to day 16 of learning DSA and development. So today in the development part, I started learning the Spring Security, in which I learned two topics till now. The first topic is the security attacks and the second topic is the internal working of Spring Security. So moving on to it, first I will explain the attacks. So the first attack is the cross-site request forgery, CSRF. I will speak 2 to 3 aspects. Okay, the first aspect will be about the what is the how that security means how that attack happens. Second, how we can avoid it. So how this CSRF attack happens. First, you need to be authenticated in your browser. For example, you are authenticated on a banking portal. So in your browser, you will receive the session ID. But if you click on any malicious request, then what will happen? You will be in the session ID will be then transferred, and on your behalf, the attacker will process the request. So this happens in the cross-site request forgery. But one thing is important: the user must be authenticated in this case. Then moving on to the second, that is the cross-site scripting. Okay, so this is the diagram representation of how the attack happens. Then moving on to the second, that is cross-site scripting. Okay, so I forgot to tell about the how we can avoid it, measures to avoid it. So the first thing we can do, we can use the CSRF token along with the session ID to check whether the request is coming from a valid resource or not. Then second thing we can do is we can either go stateless and manage authentication with the help of JWT token. So these are the measures which we can implement for this attack. Then moving on to the second attack, that is the cross-site scripting. For this attack, the attacker will insert a script in the HTML. For better understanding, we will move to its diagram. So over here is the attacker. What will the attacker do? He will store a malicious comment and script it. Okay, then he for example added this in the YouTube, and the user then clicks on the link and the script is loaded. Then the attacker will steal all the info stored in the browser, all the session IDs. So this is the cross-site scripting. And moving on to the measures. So what are measures we can do? We can do the input validation and output encoding. Okay, input validation and output encoding. As in my earlier videos, I have told you that in Spring we have the validation. We can add validation on the various fields. So that's one measure, and the second is the output encoding, which can be implemented with the help of HTML utils, .html escape. Okay, the third is the SQL injection. What happens? The attacker execute arbitrary SQL query on the database by injecting malicious SQL code. So for example, this is the query to get an user with the help of username. So what the attacker will do, he will pass the input as 1. So as he will pass the input as 1, the resulting query will be this, and this will lead to means the data will be exposed to the attacker. So we can avoid it. The measures we could take is, first we can use the prepared statement for it. Then second is the employ ORM, and third is the validate and sanitize inputs. Okay, so this was the first part about the attacks and their measures. Then the second part was the internal working. So speaking about the internal working, first we need to add the dependency in Spring Security. We need to add the dependency of the Spring Security in pong.xml. Then there are two words over here. First is the authentication and authorization. So authentication means validating an user based on the credentials provided. That might be email username, password, etc. And the authorization is when you have control for a particular operations. For example, role based. If you are admin, you will have access to admin level operations. Then if you are user, you will have the user related operations access to that. So that comes under it. Then moving on, internal working. So this is not that much important, but I will actually show you with the help of the diagram. Okay, so this is the internal flow. But what we will do, we will not focus on this internal flow. We will deep dive into the internal flow, which is in the next PDF. Okay, so give me a minute. Okay, so this is the zoomed in flow. First, what we'll do, the client will provide the credentials, which will be then passed to the authentication manager, which is an interface, and it has one method, that is the authenticate method. Then from the authenticated manager, uh, means it is an interface, so it is implemented by the provider manager. So it has the list of providers. Okay, then it will go through the each provider. Then there is an authentication provider which has two methods, the supports and the authenticate. The supports will check whether that provider has support or not. Then from here we can implement various methods that are in the diagram. As we are able to see, we have implemented the DAO authentication provider. It then fetches the user details. Either it will fetch the user details from in-memory user detail manager or the implementation which we have provided. Okay, then then it has also a interface, that is a password encoder. It has two methods, encode and matches. Actually, the encode helps in the sign up. Okay, and the matches helps when you have the current password which is been sent, and we fetch the uh, password which is saved in the DB for that user and then match it with the help of the bcrypt encoder. Okay, so this was my today's progress in the development. Then moving on to the DSA. In DSA, I solved two problems. The first one was the to detect the cycle. Okay. Then second was the middle of the linked list. So speaking about the intuition of the middle of the linked list. So there were two approach. First is the brute, and then is the optimal. The brute was to find the length of the linked list first. Okay, by traversing all the nodes. Then after I found out the length, I I analyzed how the length is related with the middle of the node. So the connection between them was that it was the n by 2 plus 1 times. So what I have done, okay, so this is the optimal approach. So found out the middle node index, then traversed again. When the middle node count becomes 0, that is our middle node, and we break over there. So temp points to that node and return it. So this optimal approach is using the tortoise and hare. Okay, so what we have done, we have first initially pointed the slow and fast pointer on the head, but the slow will increment by 1 and the fast will increment by 2. So that what we have done till the fast becomes not null. This condition is for the even if the length is even, and this condition is for the length is odd. Okay, then we increment the slow by 1, fast by 2, and return the slow pointer as it points to the middle of the linked list. Then after that, detect a cycle. I have actually tried the brute and the optimal. So the brute was, we take an map data structure to store the count, that it was whether it was visited or not. So what I have done, the temp points to the head, initialize the map data structure till the temp is not null. We check whether we have visited it or not. If we visit it again, then in that condition we will return true. Otherwise we will put it and then go to the next node, and if not, return false. Okay, but over here in the optimal approach, we have the tortoise and hare again. So what we have done, point the slow and fast on the head. Slow will increment by 1, fast will increment by 2. The same condition for the while loop. And if what happens in this case, in the detect cycle, the slow and fast will point to the same node if it is a cycle. So how that happens is, there is the net difference of 1 between the slow and the fast pointer. So it decreases by 1 and gradually it becomes 0 when we increment the slow pointer by 1 and fast pointer by 2. But instead, if we increment the slow pointer by 1 and fast pointer by 3, the net difference will not be 0. So in that case, we cannot actually implement it. So that's it for today's video. Stay tuned for day 17. Thank you.